Good afternoon, everyone. Because of the current situation, I'm we have to cancel this additional classes. So I decided to take a video, shoot a video, and share this video with you. Today, I'm planning to talk about the time value of money, right? So today's our key concepts. Future value, we'll talk about the future value, present value, annuities, rate of return, amortization, and at the end of this class, a little bit the bond valuation. First of all, we need to start with the timelines, right? Timelines show the timing of the cash flow. Zero means that today, time zero is today. The time one is the end of the first period, right? And the beginning of the second period. So this period might be year, month, quarter, or even a day, right? So here we have the interest I percent for per period. This interest rate is the per period interest rates. So if it's a 1 year, if our period is 1 year, then the rate is the 1 year rate. If it's an 1 month, then this is the one month period of rate. So per period rate. So be careful about it. In finance, the interest rates are always quoted annually. So when it's quoted annually, if it is the monthly period, then you need to divide this annual yield to 12, right? So be careful about the per period interest rates. Let's draw the $100 lump sum due in 2 years and 3 years $100 ordinary annuity. So we have two different cash flow in this example. If you draw the first one, $100 lump sum due in 2 years, here is the cash flow, right? So as you have seen, the $100 is paid in 2 years' time. The interest rates, the annual interest rates per period is I. It doesn't say anything, but I. So if you want to find the present value, we'll see, we need to discount for 2 periods. But this is a one shot, payments, right? We don't have any series of payments in the first one. The second one is 3 years ordinary annuity. So in this case, we have the series of cash flow, same amount of money for the 3 years. So $100 next year, $100 2 year time, $100 in 3 years time. Of course, the interest rates per period interest rates. This I'm sorry, this cash flow might be uneven, right? So depending on your project, you may have a uneven flow stream. Like in our example, this year we have to pay 50 minus indicating the outflow. So 50 means, minus 50 means we are paying something else, someone else for this cash flow, for this asset. So it's an outflow. So next year we will receive 100, 2 years time, 75, and 3 years time, 50. So this is the uneven cash flow. It might be the case, right? So how can we find the future value and the present value of any cash flow? As you all know, today's $100 or 100 AZN is not the same as the next year $100 or 100 AZN. Because of the interest you are earning from this $100 for 1 year, this two cash flow is not equal, right? Today's is more valuable than next year's the same amount of money. So based on this concept, we need to discount or compound the cash flow. If we want to find the future value, we need to compound it, right? In our example, we need to find the future value of $100 with 10% interest rates in 3 years' time. So in the first year with 10%, we will get 110. In the second year, we start with 110, 10% return, it's going to be 121. In the third year, we start with 121, again 10%, and we end up with 133. Right? So, well, why not it's 130 but 133? Because we are getting interest of interest. Right? In the first year, we will get 110, which is the $10 is your interest earning. And the second year, you will get 121. The $10 is the interest of 100, and the additional $1 is the interest of interest, last year's interest. You get additional return on your interest as well. So we are repeating 3 times, then we end up 133, right? In general, the future value is equal to present value times 1 plus interest rates over n. So how many years we have? Right, let me write and show you. Your future value is equal to present value times 1 plus interest rates over n. So this is the general formula for calculating the future value of single cash flow. Of course, we don't have a series of cash flow. We have only one single cash flow, right? Basically, it means that in our example, our future value is equal to, future value is equal to present value 1 plus interest rate times 1 plus interest rate times 1 plus interest rates. So with 3 years, our cash flow, our formula is our future value should be equal to present value, which is 100 in this case, times 1 plus interest rate, which is 10%, times 1 plus interest rate, 10%, and 10%. So altogether, which is future value is equal to present value 1 plus interest rates over 3. So we can rewrite the equation like this. Right. Okay. So we can find the present value. We can do the reverse as well. And this process is called discounting, the reverse of compounding. Basically, if you know the value of future value of any cash flow, in 3 years' time you will receive $100, and what's the value of today? Now we need to discount, we need the same thing, right? Exactly the same thing, but we need to rewrite this equation and find the present value. Basically, future value divided by 1 plus interest over n. You see, exactly the same thing, but this time we are discounting. So we know the future value, we know the interest rate, we know the n number of periods, then we can find the present value. Right. So if we discount this, we end up with this one, 75.13. So it means that you can compound 75.13 with 10% for 3 years, you end up with $100, or you can discount the $100 with 10% for 3 years, you end up with $75.13. So it means that $75.13 is equal to $100. You have to be indifferent with these two cash flow with the 10% interest rates environment. So it doesn't matter which one. We cannot say that the present value or the 75 is worse or better than the $100, right? With the 10% interest rate environment, of course, with this assumption. Right. Let's move on to the next slide. As I told you, interest earned on interest is called compound interest, right? If there isn't any, we call it simple interest. So if it's a 1-year return without any interest on interest, then it's simple. But if it is compound, then it means that you are getting interest on interest, right? So question, at the beginning of your freshman, your university, your uncle deposits $10,000 into a 4-year bank certificate of deposit, means that in a bank for yourself, that pays you 5% annual interest. You will receive the money in the account, including the accumulated interest, which is the compound return, if you graduate with honors in 4 years. How much there will be in your account after 4 years? Basically, let's use the same concepts, same formula. Basically, the question is asking for the future value. And the present value is the $10,000 with 5% for 4 years. So this will give you the amount of money in 4 years' time. So it's 10,000 is compounding for 4 times with 5% rate, right? So as you have seen, it's equal to 12,155. Of course, it's more than 12,000 because 155 is the interest on interest, right? So that's why we have more return. If you decrease the time periods, compounding periods, then you will get more, right? So here is the growth of $1 at the various interest rates. So over the 10-year periods, we start with the 1%, $1. If the interest rate is 0, then 10 years later, it's again $1. If the interest rate is 5, then you have a slightly, in 10 years time, it's slightly higher than $1. If the interest rate is 10, you are doubled your amount of money. If the interest rate is 20, then you'll see it's more than 6, right? As you have seen, the interest rates over time, and both time and interest rates, has a huge effect on money. Right. So this is the annuity, well, cash flow of annuity. So you will have the same amount of money, the payments, right, in both let's go with, yes, in both every years, let's say. So if it's ordinary annuity, the payment should be at the end of the periods. If annuity due, this payment should be at the beginning of the periods, right? So basically both are the same, but annuity due receive the payments immediately, right? So ordinary annuity, we don't receive it. We have to wait until the end of the period. Annuity due, receive immediately. So this is the basic differences. Of course, the present value and the future value of these annuities and ordinary annuity and annuity dues are different. Assume that, let's see an example. Assume that you will deposit 100 ASEAN at the end of each year, so ordinary annuity, for 3 years, and the interest rate is the 5%. How much you will have at the end of third year, right? Basically, let's draw the timeline first. So the first year, second year, third year, and the 5% is the interest rates. Right. So here is our cash flow timeline. So at the end of each year for 3 years, year 1, year 2, and year 3, we are depositing 100 ASEAN, right, with the 5% interest rate. So we try to, let's go back, we try to find the future value. What's the future value? We can do it in 2 ways. The easiest way, we can compound each cash flow to the end of periods, right? So this 100 is carried forward compound to the year 3. This is compounded to the year 3. Then you can add them all, right? So let me write the formula for the first one. 101 plus 5% for how many? 1, 2 years. The second one is the 105 for 1 year, and the last one is the future value is the already 100. So this the red boxes, right? I'm carrying forward to all cash flow. The first one we have 1, 2 periods, so I did it twice for the first one. The second one we have only 1 period, so I compounded for the 1 year, and the last one is already 100. The future value of 100, it's already given. So as you have seen, when you add them all, you can find the future value of this cash flow. Of course, if it's a 3 years, it's easy to do it manually, one by one. But if it is a, let's say, 20 years, it's not easy to do it for 20 years. It takes time. So in this case, we need to use the formula, right? So this is, we can generalize this cash flow and end up with the given formula. So the future value of an ordinary annuity is the payment, PMT is the payment, cash flow, 1 plus interest rate over n minus 1 divided by interest rate. So this formula gives you the future value of a given cash flow. In this example, in our example, payment is 100, right? So we are paying 100 ASEAN every year. 1 plus interest rate is the 5%, so this part is going to be 1 plus 105 over n for 3 years minus 1 divided by 0.05. 0.05 is our interest rate, right? So we can find the future value with this one single formula. By the way, you don't need to memorize the formula, but learn what it is. Another question, your grandfather urged you to begin the habit of saving money early in your life. He suggested that you put a $5 on an envelope every day. If you follow his advice, at the end of the year, you will have 1,825. So which means the $5 times 365, right? Then at the end of each year, you invest this amount of money in a bank with the 8% rate, right? Now you're 18-year-old. If you start following your grandfather's advice today and continue this saving for rest of your working life, right? How much would you expect to have in your bank account when you get retired, when you get 65, right? So we have the series of cash flow, 1,825 each year, right? For how many years? 65 minus 18, right? For 47 years, right? Then we can apply our formula. In this case, the interest rate is given as 8%. The present value is 0. We don't have anything right now, but we start to add $5 on a daily basis for 47 years, right? So the payments, yearly payment is 1,825. At the end of age 65, you will get 826,542 dollars, right? You see the power of compounding. Just you are putting almost 2,000, less than 2,000 on a yearly basis, but you end up with 826,000, right? Let's see the future value of ordinary annuity. You remember the ordinary annuity, the difference between ordinary annuity and the annuity due. Annuity due starts earlier than ordinary annuity, one period before, right? So in this case, you can calculate the future value of ordinary annuity, and we know that we have a one period differences. Then we multiplied with 1 plus I, 1 plus interest rates. So it gives you, of course, more amount of money. In our example, annuity due is higher than ordinary annuity. The future value of annuity due, of course, higher than future value of ordinary annuity, right? Let's talk about the present value of ordinary annuity. Remember, this is the future value. Now let's do the same thing with the present value. First, draw the timeline. So we have 3 years, 1, 2, 3 years, right? 3 years, paying you 100 each year, right? So we need to find the present value. So this time we need to discount each cash flow and add them all, right? You see, we know the future value is 100, so we can discount it with the, of course, given interest rate should be 5%. I've forgotten to write here. So per period interest rate is the 5%. So we are discounting 5%. This 100, next year 100 is less than, of course, today. Less than the 100, but we need to discount it with 5%. The second year should be discounted and the third year should be discounted. Let me write the formula here. So the first one is the 100 divided by 105, right? The second one is, let me write with a different color, 100 divided by 105 square, and the third one is 100 divided by 105 to the power of 3, right? So when you discount each cash flow, once again, 100 divided by 105, the second one, 100 divided by 105, but for 2 years, and the 3 years. When you add them all, you can find the present value. Again, with the few years, with the 3 years, it's easy to do that, right? Like this one. But if it's a series of cash flow for more than 20 years, you cannot do that. So this is the basically formula for finding the present value of an ordinary annuity. Again, PMT is our payment, right? In this example, it's 100. And 1 minus 1 divided by 1 plus interest rate, here is the 5%, over n, 3 years, divided by 0.05, which is the interest rates. So this formula gives you the present value of the ordinary annuity. So once again, be careful about the series, the ordinary annuity. Okay, here is the question. You won the Florida lottery. To receive your winning, you must select one of the two options. The first option is you can receive $1 million a year at the end of each year for next 30 years. So ordinary annuity, it's not annuity due. End of year, because it says. So you can receive one-time payment of $15 million today. And assume that the interest rate is the 6%. So which one is the most valuable options? So which one do you prefer? So you know that in this cash flow, you know that you can receive one-time payment today, 15 million. So the present value of this cash flow, 15 million for the second option, but we don't know the first option. So we need to find the present value of the first option. It seems that 30 million for 30 years, it gives you $1 million. It's great, but we have to calculate with the 6%, of course, and find which one is the better option, right? So we can calculate it with our present value formula, right? For the second option, it's already a 15 million. We don't need to do anything for the second option. For the first option, the payment is $1 million, and the formula, the interest rate is the 6% for 30 years, right? So we plug everything in the formula, then we calculate the present value of this cash flow. So obviously, the present value of this cash flow is 13.7 million, so less than 15 million, so it's better to go the second one. It's better to choose the second one, right? Okay, let's move on. Perpetuities. Well, perpetuity is another approach. So if you receive this cash flow, same amount of money for infinity, every year, forever, then we can talk about the perpetuity, and we can calculate the present value of the perpetuity. Basically, if n is infinity, then we end up with the payments divided by the interest rates, right? Okay, what's the present value of uneven cash flow stream? So we can find the present value of this uneven cash flow stream, but we don't have any formula to do that. We have to do it manually, one by one. So we need to discount each cash flow, right, with the given interest rates, and find the present value. Then the summation of all this present value gives you the present value of this cash flow stream, right? So we don't have any formula for that. We have to do it manually, one by one. Okay. Right. The power of compounding. Let me check the power of compounding part. Okay, let's do this one. Then I'll continue. Okay. A 20-year-old student wants to start saving for retirement. She plans to have a $3 a day, this time not $5, but $3 a day. Every day she puts $3 in her drawer. At the end of the year, of course, the accumulated amount is $1,095, right? Then she opened an account, she's investing with the expected annual return of 12%, right? So how much money she will have when she's 65? Here's the question. So we know that, so it says end of year, so means that ordinary annuity. Cash flow is each year end of period 1,095. We know the interest rate is 12. It's okay. For how many years? So she is right now 20 and she will be 65. Okay, we have 45 years. N is equal to 45. Then we can calculate it, right? So if you calculate it, it's the calculation is not here. It's going to be 1.4 million. I'm sorry. It's going to be 1.4 million, something like that. Please calculate it by yourself. Then let's compare this amount with a 40-year-old investors, right? Remember, the first one is the 20-year-old lady, and this one is the 40-year-old investor. So if you do that, if you calculate with the 40-year-old investors, everything is the same, right? The interest rate is 12%. The amount of money is the 1,085. It's minus because it's outflow. That's why you are paying. You are putting in a bank, so that's why. The future value of 40-year guys is 146,000, but for the 20-year girls, it should be 1.4, even more than $1.4 million. So please calculate it for 20-year girl. You'll see please calculate for the 40-year investors. Then you see the differences. So this differences shows you the power of compounding, right? Right. If I'm not mistaken, for this lady, this almost $1.5 million is the amount that she will end up when she will be 65. Right. This fourth year guys wants to end up with almost 1.5 million. Then for 25 years, he has to accumulate $11,000 on a yearly basis. You see the differences, huge differences. Right. I mean, do this calculation with 40 years and 20 years by yourself, and you'll see the differences. Right. So let's say this is your homework. Will the future value of a lump sum be larger or smaller if it compounds more often? Of course, it's larger, because when you compound more frequently, means that your interest on interest is going to be more. So you will add your interest to your savings more often than you will get interest on interest more often. So it's going to be larger, right? So remember our 3 years example. We are with one single cash flow, of course. Now we are not talking about the annuity, but we are talking about one single cash flow. So the 100 for 1 year is compound with 10%. For 3 years, then we end up 133.1. But if we do that semi-annually, means the interest rates, once again, quoted annually, 10%. If we are talking about semi-annually, then per period interest rate should be 5%, the half of it, right? The 1 year is 10%, the half should be 5%. So we compound for 6 times, right? Because we have 6 semi-annual periods in 3 years' time with 5%, not 10, but 5%, because it's half of it. Then we end up with more, 134, because the interest on interest is now higher, right? So you will receive your interest earnings more frequently. Then that's why you end up with a higher, larger amount of money. Right. Classification of interest rates. We have nominal interest rates, right? So this nominal interest rate ignores the compounding effects. Usually, it's given like the annual nominal interest rates, right? So 8%, if you stated per period, let's say 8%, then you have to say it on a daily, on a quarterly, on a monthly basis. But this 8% is the annual interest rates. 8% daily interest rate doesn't mean that it gives you 8% every day. 8% is the annual, then you need to divide 8% to 365, then find the per period daily interest rates. So be careful about it. Always the interest rates are quoted annually, right? Then of course, might be, if it says periodically, then you know it. I mean, if let's say 2% quarterly, if the periodic interest rate is 2% quarterly, means that per period interest rate is 2%, annual interest rate is 8%. But this time, I'm saying that periodic interest rates. I'm not saying nominal interest rates, right? So basically, per period interest rate is the nominal interest rate divided by number of periods in a given year, right? And we have the another interest rates, effective annual rates, right? Or equivalent. So effective annual rates means that instead of compounding, right, what is the equivalent of annual rate? I mean, you may compound it on a, let's say, quarterly basis for 4 times. Instead of compounding for 4 times, what if I invest for a 1 year, right? So what's the equivalent rate of investing today and receiving at the end of the year and compounding for 4 times? Basically, let me show you on a timeline. So let's say 1, 2, 3, 4. So 1 year. So this is the first quarter, second quarter, third quarter, and 1 year. So you may invest 4 times a year, right? You may invest 4 times a year, quarterly, right? Let's say 2% per period. Of course, 1 year investment is more than 8% because you are receiving coupon 4 times a year. So it's going to be more than 8%, right? So what is the equivalent of investing 1 year, the red one? So instead of investing 4 times and getting the 4 times a return on a year, what if I invest for 1 year, the red one? So this is the effective annual rate. So we are talking about annual rate, but effective annual rate, right? So here is an example with the 10% semi-annual investments. So per paid interest rate is 5%. Let me show you on a timeline. So we have 1 year, 6 months, 1 year. So the 10% is the rate, the annual rate. Per period rate should be 5%, right? So we have 5% per period rate in the first period, then the 5% in the second period, right? So our return for 1 year is 105 square. So our return for whole year is 105 per period. How many times? 2 times square. So it gives you the whole 1 year return. So instead of investing 2 times, you can invest with, let's say, 10.25% per year, right? Or like this red one. So investing with 5% per period 2 times, or investing for 10.25% for 1 year. So both are the same, has the same return, right? So this is the effective annual rate. So why do we need to calculate effective annual rate? Because we may have a different investments with a different time periods, 3 months, 6 months, 9 months, right? So which one is a better investment idea? So we need to compare these 3, 6, 9 months investments, but we cannot do it with their return only. So we are just using the same base, which is the 1 year, which is the effective annual rates, to compare them, right? Right. effective annual rate, if it is 10% annually, 10%. If you calculate it quarterly, then it's 10.38. If it is monthly, right, it's 10.47. If it is daily, it's 10.52, right? Can the effective rates be equal to nominal rates? Yes, of course. If it is 1 year only, then if the period M in this case per period, I mean, how many times you are investing in a 1 year time. If it is 1, then it's same. If not, then the effective rate is always greater than the nominal rate because you are compounding more frequently. If you have 2 periods in a 1 year semi-annually, then effective rate is, as you have seen, or 4 periods, as you have seen, it's more than 1 year. Right. When each rate is used, once again, it's always quoted nominally, right? The interest rate is always quoted nominally. If you see anything rate when you want to take a loan from the bank, well, let's say 10% loan rate, then it's quoted annually. This loan might be for the 2 years, for 3 years, but still it's quoted annually, 10%. Per period interest rates, well, you have to indicate it's per period. If the period is in a 1 year, if it is 1, it's both are equal, as we say. But if not, if let's say the 10% annual rates paid semi-annually, then this 10% should be divided by into 2, and 5% is per period interest rates, right? And effective annual rates, once again, we use to compare with different payments in a year. So we have a 9 months, 6 months, 7 months investments. So which one is better? We need to compare. We cannot compare it with 6, 9, and 9 and 7 months. Once again, we need the same base, which is 1 year, which is the effective annual rate, to compare this different period of time. Then, of course, we'll choose the highest or lowest depending on what we need to do. Okay, let's see what is the future value of $100 after 3 years with 10% semi-annual compounding and quarterly compounding, right? And here is the semi-annual compounding. So we have 10% here. We divide into 2. Why? Because we have semi-annual compounding, right? How many times? For 3 years, in 3 years' time, we have 6 periods. So we calculated 105 over 6, right? So the future value of $100 compounding semi-annually twice a year for 3 years is 134.49, right? Let's calculate it for quarterly. If you calculate it, do it by yourself. If you calculate it quarterly, then 10% should be divided into 4, because we have a 4 periods in 1 year. And how many periods we have in 3 years? 4, 8, 12, right? So 12 periods, and per period rate should be 2.5, right? 1 plus 2.5 over 12. So please do it by yourself. Loan amortization, well, basically, this is the another application of annuity and annuity due calculation. You can do it with your Excel file or with the financial calculator. You can easily calculate it. I strongly advise you to find a financial calculator instead of scientific. I know it's hard to find it, but if you can, please find it and use it. Let's make a basic assumption. Well, we have $1,000 with 10% annual rate within 3 equal payments, right? So it's an application of annuity formula once again. If you know the present value and if you know the interest rates, you can calculate the payments, right? Please go back and check the previous slides and you'll see the formula. Once again, you don't need to memorize the formula, but it's good to know how to use it. Okay, if you have a financial calculator, you can easily calculate it. We'll see, we will do it, we'll calculate it manually, but right now we have a 3 years with 10%, and right now it's 1,000, then the payments for 3 years should be 402, right? And at the end of the 3 years, we will pay our full loans, nothing left. So the future value will be 0. Let's start from the beginning. So we know that we took $1,000 and the interest rate is 10. So at the end of year 1, we have to pay it $100 as a interest payments, right? So the remaining 402 out, the first payment is 402. For the remaining 302.11 must be paid from the principal amount, right? So the principal payments is 302. For the next year, following years, our beginning balance is not 1,000 anymore, but 302 less, which is 697 in our example. So the payments, the interest payment is the 10% of 697, right? So here is the table. So we begin with the 1,000 and the same amount of money, 402, is paid on a yearly basis. The first year, the interest payment is 100, which is the 10% of beginning balance. And the remaining, because we are paying 402, and the remaining 302 is the paid by from the principal part. So the ending balance is 698, right? So the next year, the interest payment is the 10% of this amount, 10% of 697. And the remaining 332, which is altogether 402, is your principal payments. And ending balance is go down to 366. Same process, apply the same process, and as you have seen, the 1,000 principal will be paid. The interest payment is 206, and altogether 1,206.32 will be paid, right? With the 10%, of course, in 3 years' time. So this is basically the amortization table of a 3 years year-end loan payments, right? So you see each time the principal payments has been increased and the interest payment has been decreased accordingly. Right. Here is the question: if you want to buy a car and want to lend 20,000, the loan will be fully amortized over 5 years, and the nominal interest rates will be 12% and paid monthly, right? So what will be the monthly loan payments? Let's calculate it. Let's see how we can calculate it. First, we need to know the formula. You don't need to remember. Here is the formula for it. So the present value is the 20,000. So it's the amount of loan right now, right? For 60 months, the interest rate is 12% nominal. So per period should be, if it is paid monthly, then 12 divided by 12, 12% divided by 12 months. So the 1% per period interest rates, right? So when you plug the numbers into the formula, 20,000 should be equal to the cash flow or the payments, monthly payments, times 1 minus 1 divided by 1 plus 1% for 60 months over 1 divided by 0.01, it's 1%. So the only cash flow is unknown, so you can easily calculate the cash flow. So we know that each month we have to pay $444.89, right? So what's the effective annual rate? The second part of the question. We know that effective annual rate is the nominal rate divided by, because we have 12 periods, right? 12 periods in a 1 year. So we are looking for an annual rate for 1 year, right? So we have 12 period in 1 year time. Then 1% per period for 12 months is equal to 12.68%. So actually, if you pay on a monthly basis with 12% nominal interest rates, the equivalent rate is not 12%, but 12.68%. So more than 12%. Actually, what you are paying is 12.68% on a year, which is the effective annual rate, right? So this is the end of our slides. One more thing I may add is the bond calculation. Basically, bond calculation is the same as present value calculation, but one more thing, let me show you on the timeline. So the typical bond has this cash flow. I mean, pays you the coupon payments on each period until the end of the maturity, plus pays you the face value. So you can discount each cash flow individually and find the present value. This is one way to do it. Or alternatively, you'll see the annuity formula. For this coupon payments is the same amount of money for a given period of time. So you can use the annuity formula, find the present value using annuity formula, plus, of course, we have an additional face value, plus you need to discount this face value separately, right? So basically, it's same as the annuity formula with an additional face value discount. So be careful about the per period coupon payments. I mean, it might be a year or paid semi-annually or quarterly if the coupon payments are quarterly, so be careful. So this interest rates here, I% written in the red here, this I% should be per period rate, so be careful about it. So this is the basically the same concepts. Okay, guys, under these circumstances, unfortunately, we have to, I mean, I need to cancel the classes, and instead of the online classes, I decided to go this way. Hopefully, this problems will end soon, and the Karabakh will be back to Azerbaijan, hopefully in the near future. Thank you, guys. See you.